Okay, thank you so much, guys, for joining again. So in this class, we are going to continue looking at different DataWeave functions. Today, we are going to build a project with real-world data and apply various DataWeave functions, transformations, filtering, also data extraction, and calculating summary statistics. The project, as before, I have pushed it to GitHub. You can get it from here. So this one is a project, and the data for it is web server log data from NASA. So it is this one. The data is actually very big. Just I have uploaded a sample. So the sample data, let me open it and show you. So okay, so this is the data. I want to show you what fields it has. So I will increase this column width, let's say to 15. So basically there is a host here, and we see the date time zone, endpoint, status codes, the different HTTP status codes, and size returned. So when someone sends a request to the NASA website, this is log data. So it's just log activity data. So we want to process this data and see, for example, which status codes are common, or if there are any error status codes, the size of the data returned, the common endpoints, and so on. You can process this data and ask different questions and answer that. So let me get back to here. So these are the functions we will cover. We will see what map and filter do. These ones, we just touched them last time. We will see them in detail, use them especially with filter. We use them mainly with filter, like filter data. If it starts, if the string starts with something, or if it ends with something, or if it contains specific characters and so on. These ones, we use them for filtering data mainly. I will see in the example. These are simply simple functions like rounding to the nearest whole number, calculating an average, minimum, and maximum. And also the other thing is we are going to see data type conversion. So the data, this Excel, when MuleSoft reads it in, like the date time, for example, it will be string, and the size returned will also be string by default. So we will change them to their appropriate data type, to local date time, and the size also to number. And in cases where the cell is empty, for example, since it cannot change it to these specified values, we want to coerce it and give it a default value. So we'll see also setting default values. And once we convert this date time, let me increase the font maybe so that you can see it. Once you increase this font, once we this string, once we change it to date time, then we can extract the different fields from it: the year, the month, quarter, hour, day, and so on, that we saw last time. So we will do that also. So okay, now let's start with map and filter, what they do. So I have the DataWeave playground here, and let's go to the documentation. We are in core, still in core here. So we have these different functions here, and we are looking, let's start looking at, let me increase the zoom level here. So we are looking at map. So it says it iterates over items in an array and outputs the results into a new array. So map, the input is an array, and the output is also an array. Let's see an example. So like we know, like for example, if we want to create an array from 1 to 10 inclusive, we can simply write 1 to 10 like this, right? So we have this array, let's say this is our input, 1 to 10. Now let's say we want to double the values here. So we cannot simply do like this, like in other programming languages. You can just multiply the array by some number like this, but now it doesn't work. Rather, what we do in DataWeave is we iterate one by one and do any kind of operations on each element that we want. So here we have 10 elements that you see. And the other thing is each element has its corresponding index. Index means just like if it is in Excel, the raw number starting from 0. So we have this one, index 0, index 1, index 2, and so on. So we have value and index, and we can do different operations on the index and on the value. So we use map if we have an array and we want to implement any data transformations. We can use map, and there are two ways of doing that. That is what we are going to see. The first one is just to do map. And so there is value and index. So the values are 1 to 10. The first time the value is 1, the index is 0. The second time the value is 2, the index is 1, and so on. So once we do like this, now I can just do like this. So value times, let's say 2, we want to double it, right? So see now what we have done. The index, we are not using it here. There could be times when we want to use the index, but in this case, we are just iterating over the values. So 1 to 10, this part creates an array for us of 10 elements, and we are iterating over each element using map. Each element has a value and an index, and then from that value index pair, we just are multiplying the value by 2. So this way, we are iterating one by one. So it can be anything, multiplying by 2 and so on, or we can even square it like this. You see square of the numbers 1 to 10. You see 1, 4, 9 up to 100. Or we can also find the square root just to cover for completeness sake. There could be some times where you need to use all of these functions in some way. So it is good if you know them. So there is square root here, returns the square root of a number. So I can also do square root of value, for example. So you see, we are iterating over each element one by one, and we are getting the square root. So as you can see, the input is an array, right? So if I just comment this out, the input is an array 1 to 10, and the output is also an array. Our input are numbers, as you can see. Our output also in this case is numbers, but we can make it anything. The output can be an array of objects or an array of numbers or anything. So let's make it an array of objects, for example. So if it is an array of objects, what we have to do is we start with these curly braces. As you can see here, I will wait you for now. Okay. So as you see, let me take this here, make it one line. So our input array, numbers, we want our output to be some kind of array of objects. So I removed the comment. And as you can see, if this is for each element, it is creating an object with an empty object, right? The first one, empty object, the second one, empty object. And in each object, we can put whatever we want here. There are a couple of nuances to memorize here. So for the index, you cannot just do index value. If we do just index value, it thinks this one, it takes it as a string. So this is the key, right? When we create an object, we have key value pairs, but just now it becomes simply the string index rather than 0 to 9. So when we are mapping, what we do is this one, we put it in bracket. Now it will know it is the index that comes from this map, from this mapper. So you see, we can make this new line, by the way, that could be more readable. So you see the first value is 1, its index is 0, the second value is 2, its index is 1, the third value is 3, its index is 2, and so on. So now we can, just like before also, now we can multiply this by 2, we can do any kind of operations here. So in this case, we have created an array of objects, this is one way of using map, by explicitly putting value and index. By the way, this terminology, this naming, you can give it whatever you want, but it is good if it is descriptive. Like, for example, I can put this M and this N. The second one is always index. The first one is a value. Now this one I have to put it in, and this one M. So rather than doing like this, where M and N are not where we don't know what M and N are, it is good if we put value index. That way it becomes descriptive, easy to understand what you are doing. Or you can give it object and index of object, something like that. Okay, so this is one way of using map. The second one is using just a single dollar and the double dollar signs. Let me show you that. So what we can do in that case is we don't need this value index. Rather, we simply remove this. And here, this one, we replace double dollar corresponds to index, and single dollar corresponds to value. You can also do like this. Okay, map. I don't need this. This is also another way of doing that. Both of them give the same results. So without putting the value and index, you simply do map, and then double dollar sign corresponds implicitly, it corresponds to the index, and single dollar sign corresponds to the value. But the double dollar sign, it should be the same way as before. It should be within brackets. Or we can also put it within quote. Either of them should work like this, like either like this or like this. So this is map. You can go over the documentation and see the examples. Also, we will see also in our project how we are using it. Let me just quickly go over the examples and see if there is something I didn't cover. Map is here. And okay. We have this one. Okay, so map. Okay, so it says, as you can see here, it says iterators over items in an array and outputs the results into a new array. Like in the certification, for example, you may get, they may ask you what is the output of applying map to an object, and map doesn't work with object. It will give an error. It should be with an array. And they may ask you what is the output of applying map to some kind of array. They may give you some data and map is applied to it. Then they ask you what's the data type of the output. So it should be array. Input is array, output is array is what this one is saying. So let's see examples here. We have names of people here, as you can see. Then map value index. So simply just, well, in this case, this was an array of string. Now it is an array of objects, where each object has the index corresponding to it. And the index starts from 0, as we know, 0, 1, 2. Okay, the other example, we have another example here. This is also string, ABC, map value index. In this case, it is just concatenating the index and the value, but the index rather than starting from 0, there could be cases where you may want to start from 1. So that is why they are adding 1 here. But remember, the index has to be within these brackets. Another example, this one is using the anonymous functions. So double dollar, single and double dollar signs, as you can see here and here. Please read this documentation. So you see now we don't explicitly put value index, rather we simply put map. Then here, this is the index. It can be within quotes or within bracket, both of them work. And this single dollar is the value. And the other example, this one is also a similar example. So this is map. Now let's see filter before we go to the main project. So the other one is filter. Okay, they are very similar. I mean, filter, as you know, it just filters data based on some conditions. So we have this array 1 to 10. Then I can put filter value index and simply do value greater than 10. Okay, value greater than 5. So you see our array is, if you comment this, our array has the values 1 to 10. Now we want to include only the numbers, the values greater than 5. So you see it gives us 6 to 10. Or we can put, like for example, odd numbers. Let's say odd. And if you want to get odd numbers, there is a function that calculates modulo, that is the remainder. This one, modulo here, use this function mod, and it returns the modulo, the remainder after dividing by the divisor. So 3 mod 2 is, the remainder is 1. 4 mod 2, there is no remainder. So you see 0 here, 0 here, 2.2 mod 2, also it gives 0.2. So we can use the same thing here also, mod of value 2 equals to 1. So these are odd numbers, right? So when we divide it by 2, the remainder should be 1. So you see these odd numbers. Or if you want to filter to include only the even numbers, just put okay, I'm sorry, 0 I mean. So if they are even numbers, then the remainder when divided by 2 should be 0, right? So you see the even numbers also, we can filter it like that. So this is filter. The previous one was map, and read the documentation. And the example is for filter are, where are they? Okay, this one. Let's go to filter is here. So you see, we have this number is an array. By the way, start from here. It says iterates over an array and applies an expression that returns matching values. So both map and filter are used over an array. So you see, we have this array that contains these numbers. Then we are filtering only those that have values greater than 2. Value index, in this case, the index, we are not using it. Just the value greater than 2. So you see it returns this. And here we have some source data. So the source data, it contains name and age. And filter, you see here, we are filtering only objects from the array where the age is greater than 30. Greater than or equal to 30. This is greater than or equal to 30. So you see this one and this one have age greater than or equal to 30, whereas this one has been excluded. And the other one, this one also 29, is 25 were excluded. So that is what data filtering is. You have some criteria and you include only those that fulfill your criteria. And in this case, index is also being used. As you can see, we have this data, this array, then filter where the index is greater than 1. There could be cases where you don't want the first 2 data pointers. So we don't need the first 2 data pointers. 9 and 2 will be excluded because of this. And remember, this is an AND, so it will return only from here from these items that fulfill both conditions, this condition and also this condition. So the index should be greater than 1, so 9 and 2 are excluded, and the value should be less than 5, so 5 will be excluded. So the result is 3 and 4, as you can see here. Last one, this example is good example. So we have a variable that contains this array. Okay, an array, and we want, there could be, you may want to return the users with error or with null, with some condition. And in this case, where the error is unknown or is null is what we want. So you see, users is a variable name, users filter item index. You can call it value index, item index, object index based on what the data is within the array. If it is an object, you can call it object index, or item index could be generic, or value index. So you see in here what it is doing is it returns only where the error is null. And you see, so the first item is from this array. The first item is this one. This one, the first item. So item.error equals to null for the first one is this one. The second item is this one, this object, right? This object in here. So item.error will return null. So since this will return true while checking if it is null, then it should return, the items that should be returned, it should be this one, the second one. And that is what we see here. So in this array, initially we had 2 items or 2 elements. This one doesn't fulfill the condition, but this one, it fulfills the filter condition. So that is why it returns the one that fulfills the filter condition. Last example, okay. I think I will stop here. Let's see this example and then we will continue to our project. So we have this data, and what it is doing here is return only where it is active. Okay, let me see here. In here, this example reads a JSON array. Okay, which one? This one. I'm here. So this example reads a JSON array and uses the filter function to extract the phone numbers that are active. There could be cases where you want to filter only active users, exclude inactive users, or products out of stock, and so on. So now, in this case, we are extracting the phone numbers that are active. Okay, let's see which ones are active. Under phone number, so you see we have, this is this JSON object. We have phone number here, primary index, I think, yes. Number here, active index, yes. Where are here, active index, no. Primary index, no. So this will be excluded. This one, active index, yes. Primary index, yes. So this one and this one will be returned. So this is an object. The input is an object, but the we have the key value pairs, right? So the base key, this one, its value is this objects, and we have username is string, active index are, and then phone number. Under phone is an array, as you can see here. So if you extract phone, then you have array. So you can apply filter or map on this array that you can extract from here. So how do you extract it? If the input is payload.base.phone number will be an array. So that is what we see here. So you see there is profile somewhere. Oh, profile. Okay, yeah, payload, base is under profile. Payload.profile will take us to here. And under profile, we have base. So payload.profile.base.phone gives us this array, this square bracket, everything within this square bracket. Where does it end? I think the data here is probably incomplete. Oh yeah, here. From here is a square bracket to here. So I can actually copy this and take it to the playground. Copy to clipboard and replace it here. Okay, perfect. So now this is our payload, the whole of it. This is our payload. So if we put payload dot profile, you see the keys, the upper level keys are ID, market code, language code, and the profile. So if I do dot profile, still it is an object, as you can see, which is within curly braces. Here the keys are, it is just one key, I think. Yeah, just base. So just base. You can see even just when you add dot, it shows the keys, available key, which is base. Now we have these keys: username, active index, phone, and so on. Now if I put phone, I get an array. You see, we have this array. Now over this array, I can do the filtering, and that is what we see here. So here, and here, you see filter. We can use $sign and dollar sign with filter as well. So the $sign here is the item, right? So we have item.active index for the first one. The $sign.active index is Y. For the second one is N. The third one is Y. So that's what it is doing. So where it is active and the prime also is primary, yes, as you can see. And to check equality, we use double equal. So we have double equal where both of them are yes. Then it will return the, let me copy this and show you. If I just copy this and take it here, and remove this part. So even we can just remove the rest, just have the phone number only. We kind of move this and this one to here. So what are we doing? So it is just going to return the objects that fulfill the items that fulfill this condition, where active index is Y, as you can see, active index is Y, and also primary index is Y in both cases. But we don't want the whole object. We just want the phone number from it. So just to do dot, as you can see, when I do dot from the object, it shows me the available keys. I just need the number. Now I get the phone numbers. And if the phone number doesn't exist, then you can give a default value. So default missing, something like this, or anything you can give. So this is just empty array when the phone number doesn't exist, but if it exists, it is going to return this number. So yeah, this one practice it. So when we apply filter, it just returns the items or the objects, and the object can be, the item can be key value, an object of key value pairs, and if you want specific values from that item, then you have to do dot of that key. That's what it is doing. So these examples are very nice. I recommend practicing them. And now I think these are the functions that I want to cover. Now let's go to here. I have this project. As I said in the start of the class, I have the project in GitHub, the data also. The only thing that you want to change are the paths, the location of the data. So here I have read CSV. I'm reading the CSV, change this to your location. And here, scatter gather, I'm just using scatter gather so that not to build different flows. One flow I want to create to get results where the status code is 400. Another one, rather than simply 400, I want to all of them that start with 4. So there's a status codes. We have these status codes that we saw sometime in the class, right? So we have this one, 200 is okay. Under 400, for example, we have 400, 401, and 404. So if you want to return all of them, you can't just do start this with 4 or start this with 4D in this case. If you do start this with 4, it will return everything that starts with 4. So see these functions that we are using. The first one in the filter is equality sign. You see here, equality sign. Payload is the input data. It is an array. Filter, you see value index. In this case, I'm not using index, where value.status code is 400. So when it reads in the data, it reads it in as a string rather than 400 numeric. So that's why I put it as a string here. So you have to understand the data type to appropriately handle it. So, okay, so here I read it in. In here, to apply filter and map, the data should be an array of JSON or Java. So I'm transforming it to JSON because you can easily see it. And then let's focus on this one. I am using the map here. Let me show you what I am doing. Copy this here and take this and paste it here. I hope this is visible. Okay. So what I'm doing here is we have the payload. I want to map it. Mapping could include transforming the data from one format to the other, or applying different kind of mathematical operations and so on. So we have payload, which is input array, map, providing value and index here, and I will use the values. I don't care about index. So host is simply value.host. So from each object in the array, it is going to get the host basically. Each object will be the the value. So from that object, I'm getting the host and the datetime. Let me run this in debug mode and show you what it looks like when it reads in the data. Okay, this one was running its image, run in debug mode. And so it is going to read this data, and I have the output here. I want it to output like something like this. The records that have a status code of 400 separately. Oh, I don't have any of them with 400. Actually, it is, I think, because, okay, let me see. How come this is of size 0? Maybe, okay, we'll check this why it is. And this one, where the endpoint has ESA in it. So as you can see, this one's all of them, they have ESA somewhere in the string, or this one is an image. So we will see this one by one. Let me remove the output location. Our input is the original data that I downloaded is this one. It is 26 megabytes, but it takes some time. It takes time, so I'm just having a sample of 3 megabytes from it. If you have time, I mean, if you want to experiment with whole data, I will upload this one also, and you can experiment with it. Okay, so here, this one, perspective, this is perspective. Okay, so this is deployed. Now, I want to show you as it reads in the data, the different data types, how it reads it in, and then we want to transform them to the appropriate data types that are suitable for our data transformations or filtering. Okay, so my path is, I think, DataWeave. Let me show here. Yeah, the path is DataWeave. So I will just send a request from postpan. First, let me clear this console. It is clean. Okay. And focus command is here. Send. Now, if I come here, here is the data, right? It has read it in. This is the payload. It says it is too large. The first thing is we know it is CSV. In the read operation, I specified the MIME type. As you can see, it is comma separated. We have host. The columns, you can see them: host, date, time zone, endpoint, and so on. We can also see the data type. So the first thing is what I'm doing is this CSV data, I'm transforming it to JSON, as I said here, to apply the mapping and filtering. That's the only thing. So if I click next processor, it will execute this one and convert it to JSON. That now the payload, if we click here, this is easier to see. These are the fields. So we have an array of objectives. It is showing us a sample. We have the host, which is a receiver website. So users are sending requests to a website. So we have the host, and endpoint is the exact location of the data. So we have the time. This shows when it was. So this is August 1995. As you can see, this is string. Here it is showing as string, and we want to convert it to date time, local date time. We said if it doesn't have if it doesn't have a time zone, then it is local date time. So this one will make it local date time. And we have the time zone. This is UTC+4. We have endpoint, status code. The status code also, as you can see, it shows as a string rather than as a number. So when you filter data based on the status code, if you want to get the errors, how many errors you have, and so on, you have to understand the data type. Size return. This is also size of data, so it should be numeric, but here it reads it by default as a string. So in the mapping, the first thing I did is the okay, the size returned. Let me see how I can make this more visible. Let me save it as JSON and see what it looks like. JSON file. Oh, it's crazy. Okay, so we have this payload. We use map, value index. So from each value, the host, I'm just extracting it as is, value.host. The date time, though, I want to transform it to local date time from string, because it is string by default when it reads it in. So value.datetime as, this is the data type, local date time. However, there are different ways or different formats that we can have local date time. So we have to tell it the exact format. Usually it is DD, MM, 4Y, followed by space, then HH, colon, mini, MM, colon, SS. But this is slightly different. There are different ways of putting local date time. 3M, as we saw last time, 3M is abbreviation of the months. So in here we saw, as you can see, this abbreviation of the months. So that's why I use it 3M. D is day. Y, single Y is 4 digits year. Or you can put 4 Ys. 2Y is just like the 2 digit. And then it should be the exact format. This one is, rather than space, it is colon, like in here. We have to put it as in here. See, this is if I copy this from here and bring it to here, you can see for yourself why it should match. If it doesn't match, it will give you an error. Actually, we can copy this and take it, run it in DataWeave Playground. So if I come here and remove just the body part only, and I don't want this payload, so I will refresh it to let it go. Okay. So we have this string, as you can see, this is string. Now, what I'm doing is, as datetime, if I don't specify the datetime, there is default that it expects, and if it doesn't match that, it gives an error. See, as datetime, it says it cannot cause this string, it cannot transform it to local datetime. So I have to give it the exact format. If I give it the exact format also, it should match. If it doesn't match, still it will give me an error. So if I bring this and paste it here, so what I'm doing is, let me remove this comma, this one. So now, as you can see, it knows it, and this is datetime, and I can check if I just put this in brackets. From here, I can extract different things. As you can see, you can know that this is datetime because it shows the datetime related attributes you can extract from it. So we have day of week, year, month, and so on. But if I just remove this, since it is a string, let me show you what it shows. So this is string, and if I do dot, it doesn't show anything. So yeah, we have to specify the take-home message here is it should match the exact format. You have to get the exact format of the data first. Okay, let me remove this. And if it doesn't match, if your format doesn't match this one, or even if it is empty, it is good, it is safe to put a default value in cases where it fails. So the default value I put was just empty like this. There could be cases where you have to give it real values, some starting dates, numbers, and so on, or you can just give it an empty string like this. So that is how, please practice this. That's how I'm transforming the datetime to local datetime. Then here, time zone, just for value.time zone, value.endpoint, value.status code. The status code also, it is string. I can convert it to number, but I didn't. You can try that. The size, because I wanted to calculate mean, average, and so on, you have to convert it to number. So size returned, value.size returned, as you can see here, value.size returned as number. If you have, let me show you this one also, size returned example. Let's copy this one. So if we have an array like this, and let's have another array like this, if you want to calculate the average and put a widget, it's going to give you a widget function is to get the average. It says these are not numbers. So we have to first convert them to numeric. And to do that, what we do is, let me just comment this, and just put as number. If I do like this, then as you can see here, it is numeric. So once I convert them to numeric, I can calculate summary statistics. So this one is now average, it gives me an average value. Or I can check the minimum. If I have multiple values, it gives me the minimum value. This is the smallest from these two, the maximum, and so on. So that is how you convert the data type from one data type to another, from string to number here, from string to local datetime here by specifying the datetime. The rest, these ones are just what we did, what we saw last time, but with real world data. So the datetime, I am converting it to local datetime, and then I am extracting. We have the same repetition, as you can see. I'm extracting year here, month here, month in the month name here, abbreviated form, 3 letters here, and we have day of this capital letter D is day of year. We have day of year, day of month. So day of year ranges from 1 to 365 or 66. Day of month is just the day of month. day of week also. Here, it gives us Monday, Tuesday, and so on, or it can also be abbreviated. This one, here, both of them are 4. Yeah, I think one of them should be 3. This should be a mistake. Okay. Yeah, I guess it is 3E. You can check this. For full is 4E, whereas if you want abbreviated name of day of week, it should be 3. Let me see if I have it open here. Which one is it? This one that we saw last time. Yep, here they are. This is 4E, whereas this is 3, and so on. So it is just, when you need it, you just consult this documentation, and if you don't remember it, the only thing is just understand how you do it. Otherwise, you can just see from the documentation and apply the appropriate string type. So in here, in this mapping, that is what we are doing. This mapping, it just runs this and creates an array where the data is in the format that I want. So you can see now how the mapping is important, the data transformation. That your data could be read as a string, could come as a string, but it is actually numbers, and you may want to apply mathematical operations on it. First, you have to transform it to numbers. Or you have date time related data, you want to filter based on that, maybe show only recent data, but the date time comes in as a string, then you have to transform it first to the appropriate date time before applying any kind of conditions or filters on it. So that is what I am doing here. So I will click next. So as we know, complex data weave functions, operations, we use them in the transform component. However, you can use it also, you can use them with set payload, set variable, logger, and so on. So here I have a logger, and I'm applying these simple operations. So maximum size, we said if we do double dot, it will return from the payload all size returned values. So this will give an array of numbers where the numbers are the size returned. So double dot rather than single dot. Single dot is for the first one, double dot is for all of them. So I'm checking the minimum, the maximum, and also the average of the size. These things, there are cases where they are very important, so that's why I'm covering them. You apply some conditions based on the size of your data, based on some like calculating the average. If the average is greater than some threshold, or the minimum is less than some threshold, then apply some other conditions. And here I'm using round. So once it calculates the average, it rounds it to the nearest whole number. You don't specify digits here, it just rounds it to the nearest whole number. Okay, so then here, as we said, just in the scatter gather, the intention is just to show outputting different values based on these filters. I have how many? 1, 2, 3, 4 transform messages. The first one, it filters the status code should be 400. The second one, as you can see, you can use the status with here, value.status code. You can say status with, index with, and so on. So status with 4, or I can do 40. And so it will return all status codes that start with 4, right? This status code, anything that starts with 4 is what that gives when you use status with. Especially in string processing, it is very important. If you have some string, you may want to include only strings that starts with some characters. So you can use starts with, index with, and the other one is especially contains. If you don't know where exactly it is, it could be in the beginning, in the end, or anywhere, you can use, in that case, starts with. So as you can see here, you can use contains, sorry. So I'm returning records where the endpoint contains the string USA. If I move this, as you can see, value.endpoint contains USA. See how many, how different kinds of questions you can answer with these simple functions. And this one, the question in this one could be, like, for example, how many people are requesting for images, for GIF images? This one, as you can see, so I'm putting, because the endpoint has index with GIF in that case, GIF. So these are the endpointers, and you see some of them, they end with GIF, others with HTML, others with JPEG, and so on. But like, let's say we are interested in requests for GIF images. So in this way, I know because this one, it is at the end, but it could be safer to put containers. However, containers, this GIF somewhere in the middle could mean something else, and you have to make sure it matches your pattern, it matches the pattern you want. So as you can see here, I'm using double equals for filtering. Here starts with for, here ends with GIF, and here contains yes, the keyword yes. So we have covered, basically we have seen map and filter, what they are. Go over this video, practice more. They are very important. I have to make sure you understand them well. Go over the examples as well. And for filtering, we use these functions in this way, starts with, containers. And for calculating summary statistics, we use the round, average, min, max. And also we transform with the string, local date time to local date time. And the size returned, it was read in as string, but we converted it to number, and also we set default values. And from the local date time, we extracted different date time related fields. So this one, I will run it now, send a request, and we see together why this 400 didn't return record. So let me check. Let's close this. In the original data, there are lots of 400 status codes, but in the sample I created, I will check if there are 400 codes. See the status codes we have. Oh, this is, yeah, in the sample, we don't have 400. So I will change this to, let's change it to 300 and starts with 3. So starts with 3 will return 302 and 304. These ones. But if I just want 302, I just do that equals to 302. So let me change this one. 302. And okay, this one also contains 3. Okay, let me rename this. Double click. Okay. This one, it was 302. This one starts with 3. This one also I will rename it 302.csv. And this one I will rename it starts with 3.csv. That it should be fine. Okay. So I will change the sample data then to, because I have pushed this code already to GitHub, and make sure the data I have, I want to make sure it has the status codes. So run, let's create another sample for me. So the original data I have is here. or else I can repush this code. Yeah, I will repush this modified project. That's fine. Okay. So once it is deployed, then we will send a request and we'll get done for the day. We are just filtering and specifying different conditions. You can use equals to, double equals to sign, you can use greater than or equal to, and so on. Or you can use functions such as starts with, ends with, or contains. So starts with, it returns only if the record starts with a specified value. Ends with, it returns records that end with that value. Contains returns records if they contain that value. And I'm outputting the result of each operation here on each route to the output. So this one, rather than 400 output, I will make it 302, because in here we want only records where the status code is 302. And here we want, if the status code contains 3, it can be 302, it can be 304, it can be 3, anything that starts with 3. So this one, I'll change it to 3. And the rest, I think this one, it returns records that end with GIF or images, requests for images. And this one, where the endpoint is in the US, so where it contains the string USA. Okay. Yeah, I'm sorry, I don't know how I became. Okay. So yes, that is, yeah, that's it for today. So basically we saw map and filter with real world data, because real world data is usually messy. It needs more transformation from one data type to the other and so on. So that is what we did today. And we checked the output also. This one, it should contain, the endpoint should contain USA in all of the records. So basically in filter, it returns a subset of the original data. It can be all of the data, some of it, or it can also return an empty, it can also just return nothing if none of the records fulfill the condition. Whereas with map, we are transforming the data. So we have some input array. Usually we want some transformed version of it. We don't want the input as is. So we transform using map, and we filter using, we just using filter. Let me open this and check the endpoints. All of them have ESA in them. Just don't say open. So our endpoint is here, and you can see in all of them we have ESA, and it can be anywhere because we just use it containers. So see, understand the difference between containers, starts with, ends with, and map and filter, especially map and filter, understand them well. And then next time we are going to see the remaining of the functions, map object and filter object, and other functions from the core module, and also other functions from other modules. But I think for today, this is all. Let me see if you have any questions.